Hi, this is my lab report for the third lab, magnetic field of a bar magnet. The purpose of this lab is to find the distance dependence of the magnetic field created by a small bar magnet and compare the real-life measurements with the values returned by the code. Here we're using a line chart to find the final result. The physical principles that I use in this experiment is basically Biot-Savart law for a bar magnet. In order to find the distance dependence of the magnetic field, I assume that the magnitude of the magnetic field equals to k times r to the nth. And if we take the natural log of both sides, we can get ln b equals to ln k plus n times ln r, which can be seen as a function of a line. While doing the experiments, I found that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And as the magnetometer moves closer to the magnet, the value of the x component of the magnetic field increases. The final results that I got are n equals to negative 3.452 and mu equals to 2.045. Here, n is the distance dependence of the magnetic field and mu is the magnetic moment of the bar magnet. This slide and the next one show how I approach the final result from downloading the Teslameter app to recording all the measurements that I got. I used the magnetometer in my mobile phone to measure the magnetic field created by the bar magnet at different distances. According to the measurements that are shown on this spreadsheet, I got a line chart which shows the relationship between ln b and ln r. If we recall the equation from the third slide, we can tell that the slope of this line is just n, and the intersection of this line with the y-axis gives us the value of ln k. To measure the off-axis magnetic field, I first moved the sensor in a parallel direction until the value of the x component equals to 100. Then I moved the sensor up in a perpendicular direction to the same distance and record the x, y, and z components. This slide shows how I get the results through calculations. Using a calculator, we can get the value of k from the value of ln k, and according to the Biot-Savart law for bar magnet, the magnitude of the magnetic field on axis equals to mu naught over 4 pi times 2 mu over r cubed. And this also equals to k times r to the negative third. In this way, k equals to mu naught over 4 pi times 2 mu, and mu equals to 2.045. In the coding part, I used the function given in the lab instruction to calculate the magnetic field at different observation locations. As shown in the graph, I created 2 arrows that are on axis and 4 arrows that are perpendicular to the axis. I also plug in the distance that I've measured before to calculate the magnetic field at 40 degrees from the axis. This slide shows the values returned by the calculations of the code, and in the 2 pictures, the green arrow shows the direction of the magnetic field at 40 degrees from the axis, and the 2 orange arrows shows the magnetic field on axis. So apparently the 4 blue arrows represent the magnetic field that are perpendicular to the bar magnet. There are some extra questions for me to answer here. The first one is, what if I hadn't oriented my experiment to compensate for the magnetic north? Well, in this case, the result would be inaccurate since the magnetic field of the Earth would affect the data measured by my cell phone. The second question is, what if I were to stick 2 identical magnets together? I think if B1 equals to the magnetic field created by a single magnet, and B2 equals to the magnetic field created by 2 identical magnets sticking end to end, B2 would be bigger than B1 but less than twice as big as B1. In conclusion, by comparing the n value with the Biot-Savart law that we've learned in class, I think my measurements are accurate enough. Also, my measurements for off-axis magnetic field and the calculations returned by the code are similar, which also validates our theoretical model.